Good day, everyone. I've got my computer up and running, touch Surface Pen working, also my mouse. So here we are making a how-to video, mostly by hand, to calculate the mean, median, standard deviation, and z-score for a data set that we're going to make together. With that, I have my whiteboard open, also have a blank workbook in Excel. So Excel is pretty handy in what you can do just to generate data on the fly. So if you remember in class, I typed in different states, and after a while, you'll get the option to convert these to geography, which then provides the opportunity to add in additional data. So after I typed in 3, you can convert to geography, and if you also went under the data tab at the top of the ribbon up there, it'll give you the option to select these as geography as well. Another video, another time. If I click it when it pops up, you now see almost a trifold map to each state. Let's throw in some random ones here, mostly in the south. Now let's go to Vermont. And last but not least, let's toss in Oregon. So I have 6 states, and the cool part is now if I select Arkansas, you see this almost fieldless option pull up. So if I click on that, it's going to give you different options based on knowing that it's a geography type cell. So we can get into building permits, major city, largest city, the leader, so the governor. So it is pretty handy that way of what it will pull from you, for you. I will give a caveat of some of the data is probably from an older ACS when I've dealt with it before, so not the most current, especially if the census isn't fully out yet for 2020. Let's go ahead and go down to high school, graduate, or higher. And I'm just going to type this at the top. So this is actual high school graduate or higher. And now that I have my column label, just making that a bit wider so it's easier to see, even though it didn't do it fully. With that though, you see Arkansas is at 84.8. If I click on this green box, you can double click it or just hold it down and pull it down. And you can see that we have different graduation rates or percentages across these different states, the 6 of them we have here. So with that, we see that our minimum would be 84.8, with our maximum up in Vermont at 91.8. With that though, we now have a data set that I can pull from and calculate what we need. So I already have the snipping tool open. I'm going to just copy this and then paste it into the whiteboard so we can all work from it. Copy that there, jump down to the whiteboard, and we're just going to paste it below. Alright, so you can see now we have our data set here. We have 6 states. We want to calculate the mean, median, standard deviation, and z-score. So I'm just going to zoom out and move this over a little bit. Some easy places to start is for a couple different one of these, we need to know the sample size, so our n. If you remember, if we just count them here, we have 6 states, so it's easy to identify that. So I'm just going to drop that down there, so we'll come back to it. We'll also need to know the mean for the standard deviation, and also we'll need a standard deviation for the z-score. Now let's get into some calculations. For the mean, remember you have to sum up all the values and divide by the overall sample size, which is 6. So for mean, we have 84.8 plus 88.4 plus 86.9 plus 86.2 plus 91.8 and 89.8. So you have 6 values or 6 different states here, so you want to divide by 6 at the end. And off screen I'm going to put these in my calculator, and I say take your time on this because these values are very similar. You don't want to make a human error when putting it into your calculator. Alright, so for the numerator, when I add them all together, I get 527.9, and here's when we divide by 6. We get an average of 87.98. Remember, we want 2 decimal places here. So the average state has a high school graduate or higher of about 87.98% of the overall population. take in mind that's the population over 25, so we're not counting youth in that. But I'm going to drop that down here so we have it going forward. So now we know our sample size, we know our mean. For median, this is when we have to reorder the values from smallest to largest. So again, if we identify our smallest, which is Arkansas, is 84.8. Follow that by 86.2, Rhode Island. So we have 1, 2, and then 86.9, 3, and then Missouri 88.4. That's our number 4. Since we have an even number, so keep in mind the median is usually the 50th percentile, we have 5 and 6, which would also be Oregon at 89.8, and then I should have spaced those out, but then Vermont at 91.8. We end up adding these two together in the middle and then dividing by 2, so we get the average of the two in the middle. So we have 86.9 plus 88.4 gives us 175.3, and we would divide by 2 here. And our median, and I'll just put this under our standard deviation, is 87.65. So a little less than our mean, which means we potentially have a slight negative skew. It's not off by a lot, but again, remember, if it's not all the same, there is some type of skew, non-normality, but for now, we're still good. With that, we've checked off mean, median. Now we want to get into our standard deviation. So keep in mind when we're getting into standard deviation, this is where it takes a bit more time and effort to calculate everything for it. So to provide the notation for it, and I'm just going to change to a bit of a crazier color, our formula for standard deviation is the square root. Remember, at the end we still have to take the square root, but it's the sum, that's a terrible sigma, of our value minus the mean over n minus 1. Remember, we do that to be a bit more conservative when we're calculating our standard deviation. So with this, when we get into it, we're now going to tease apart each one of these values. I forgot the square there, because if you remember, if we want to square, we've got to get rid of the negative values that we'll have in the subtraction part here. So with that, I'm going to pull it down. I'm going to pull this table down as well. And we'll work from here. I'm going to blow it up a little bit so it's easier to see. And I'm just going to go across with it. All right. So we know our mean value is 87.9. So we have subtraction. I'm just going to change this to another color. So we then have subtract, 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 subtract. 87.98. And this will give us our difference first. So we're getting the inside the parentheses first. And then we square that to get our difference squared. And oftentimes when we have a negative sign, this is what we do to get rid of that negative. So we have 84.8 minus 87.98 gives us negative 3.18. When I'm in the calculator, since I already have that pulled up, I go ahead and square it and just work across. So then I have 10.11. And I do this similar for each one. So 88.48 minus 87.98.42. Go ahead and square it in my calculator. We're at 0.17, or 8 if you do the rounding there. 86.9 minus 87.98, negative 1.08, square it, 1.17, And now hopping down to old Rhode Island, 86.2 minus 87.98. We have negative 1.78. Square that. We get 3.17. And then for Vermont, we have 91.8 minus 87.98. Did not fully put that in the calculator correct, so again, make sure you're hitting all the numbers fully. 3.82, square it, and we get 14.59. And Oregon being last, 89.8 minus 87.98, 1.82. Square that, we get 3.31. So now we've done everything in the formula that gives us our value minus the mean, squares. We need to sum all of these up for the numerator part. So here, we end up with a sum value, 10.11 plus 0.18 plus 1.17 plus 3.17 plus 14.59 plus 3.31 gives us 32.53. And here we want to do n minus 1, so we have 6 states, so n minus 1 ends up being 6 minus 1, which ends up being 5. So you take 32 divided by 5, and you get 6.51. Remember, at this point, since it's still in squared units, this is our variance. But it's hard to discuss this because it's squared percentage points or percentiles. So with that, we want to take the square root of that value, 6.51. And then we get a standard deviation value of 2.55. So I'll leave that there for a second. Check your work, and I'm just going to update our information at the top here. So now our standard deviation is 2.55. Now I'll show you in Excel just to make sure. I wanted to make sure my work was done correctly. We can calculate these values in Excel in a similar fashion, just with the formulas. Oops. So I hop in here and pull up my keyboard and go, we want our mean, median, standard deviation. We'll go ahead and calculate all of these. So for mean, remember to start any type of formula, we need the equal sign there. We'll type in average, and it starts to generate for you. Open parenthesis, and then you tell it what numbers you want the average of. Highlight those, close off the parenthesis, hit enter, and it's calculating that for you. Keep in mind, these are recognizing as a percentage, so it's already moved, so it's 87.98 is the true percentage. If I just change that up here and add in a couple of decimal places, we're in good shape, so we got that correct. Now if we hop down to the median, open it up, it's going to sort these for us, and when there is an even number, it's going to go ahead and find that for us. Again, change percent, add in a couple of decimal places, good to go there as well. And the last one to double check is our standard deviation here. So the standard deviation gives you different options. Remember, we want the sample, so .s or period s. Highlight those same 6 values, calculates it for us. We get 2.55, again, change percent, add a couple decimal places, and we're good to go. Hooray for doing it correctly. You never know doing it by hand, especially with entering items into a calculator. Take your time when you go through that. So we can see our values are correct here. So we know the average state, or the typical state here, has an average high school graduate or higher of about 87.98%. The median is slightly less than that, not by a lot though, with a standard deviation of 2.55. So remember, when we're talking about the variability or anything surrounding the range, variance, and standard deviation, we're looking at how those values compare to essentially the typical case itself. So the larger the standard deviation, the more variability or values are spread from the mean. The smaller that standard deviation, the more clustered they are around the mean. With that, let's get into now calculating a z-score, and I'll just pick one by random to hop into. And with that, just as a reminder, we use the z-score sheets. So if you're in any of the, it's not in this one, in Blackboard though, if you hop in, what folder would that be? Z-score. I thought I already had that one open. You can see here we have the positive and negative, and this is where we're going to identify where this value falls in the distribution. We'll pick out one specific state, go from there, and we'll see what it looks like. So hopping into the whiteboard. So for this as an example, I'm just going to come over here because we just need these values to work with. To calculate our z, and let me see if I can make it a little thicker. There we go. We take our value minus our mean, divide by our standard deviation, which gives us a z-score to look up in the table, and then we can see where that falls in the distribution. So out of curiosity, let's go ahead and just pick Rhode Island. So here we would have 86.2. Actually, let me go back and change up the font color again, or the drawing color. All right, so we have 86.2 minus our mean of 87.98 over our standard deviation of 2.55. So for this, put it in the calculator. 86.2 minus 87.98 gives us negative 1.78 over 2.55. So already seeing this negative sign here, we know come the z table lookup, it's going to be on the negative side just based on the division here. Divide by 2.55, and we get a z of 0.69. If you end up rounding at this point, it would push it to 0.70. So keep in mind, rounding, and I won't count off too much if you forget at that point, because this will change just a little, but identifiable. All right, so we have our z. Now let's hop back into our lookup. So we're looking up 0.70. Let me scroll down. So remember, we start on the left-hand column side. So we find the negative 0.7 and zeros at the beginning. So here we do 0.2420. If we were to do the 6.9, you can see over here that it ended up being 0.2451, so not off tremendously, but still a different number than what we're looking at based on our rounding. That's why I say if it's pretty close, especially when we're doing rounding in other parts and future statistic tests, I get it, we all do it differently, but try to stick to 2 decimal places throughout. So 0.2420 is our value here, 0.2420. What this means is essentially 24.2%. If we look at a distribution, this 24% ends up meaning that it's all the values to the left. So if this falls here, that means 24% of the other values in our distribution are less than where Rhode Island is. If we subtract 100 from that, we would know then 25.8 is to the right or greater than, in terms of high school graduation or higher, than Rhode Island. So that's how you can take that. So we know 24.2% of the sample of these 6 states are less than Rhode Island, and the other 25.8% or 75.8, sorry about that. So 75.8% is greater than where Rhode Island is. That's how you pull out, calculate the z-score, talk about where it falls within the distribution. The other part, when it gets into the interpretability, is using the mean and standard deviation together, similar to how we kind of made the distribution here. If we were looking at this and we wanted the 1 plus 1 minus 1 standard deviation around the mean to talk about where values fall. So we have our 80 mean value here. If we went plus 1 and minus 1 standard deviation, we'd end up with, and I'm going to put these in my calculator, 87.98 plus 2.55 gives us 90.53. And then if I subtract 87.98 minus 2.55, I get 85.43. And if you remember, plus and minus 1 standard deviations, so in between these values, we have 68% of our sample, 68.2. But with that, a majority of our sample falls between 85.43 and 90.53%. So that's high school graduate or higher. Out of our states, at least 68% of them fall within plus or minus 1 standard deviation around the mean. So we're just using our mean value that we calculated over here, adding 2.55, subtracting 2.55, and then we know 68.2% of our sample falls between these two values of 85.43 and 90.53. If there's questions on this, please feel free to reach out. Don't mind making more of these now that everything is finally set up. Until next time.